All right. Yeah, thanks everyone for coming out on this frigid day. I'm Carter. I'm a senior engineer here at Duolingo on the client architecture team, and I'm going to be talking about some of the AI code gen tools we've been building over the past couple quarters. Before I jump in, I want to highlight that this is very much a team effort. I'm up here presenting, but the other folks on this slide built these tools alongside me, Kush and Anthony, who are also on the client architecture team. And yeah, so as an engineer on the client architecture team, I am frequently espousing the benefits of having a good architecture in your app. And so one of the common refrains that I tend to go back to is that we want to move from building brittle sandcastles to more robust Lego towers. And this kind of translates into the sand being bespoke single lines of code and the Lego blocks being composable components. And this is still very true, but with AI, my pitch has changed somewhat subtly. So AI is very good at churning out composable components. If you ask it to build a screen for you with lots of features, it will probably crank out tons of coordinators and managers and all kinds of components for you that are quite good. But those components might not fit into the rest of your app's architecture. They might not be the same for you as the person sitting next to you. So it makes it even more important that the Lego blocks we're building, the components we're building are all good. Can you hear me now? Okay, sweet. All right. So yeah, so there are kind of lightweight solutions to this. You can just ask the AI to review your docs or look at other components that already exist in your app in order to point it in the right direction. And this does help, but I think or a lot of us have probably had the issue where it fills in the gaps in your docs incorrectly, or it looks at a wrong example in your code base and copies bad patterns. So at Duolingo, we've built a more robust flow for handling this, where we use Python scripts, cursor rules, and templates to guide the LLM through a consistent process with output that follows our MVVM patterns and codebase specific conventions. Yeah, and I'm going to be kind of throwing in some MVVM buzzwords into this presentation. If you don't really understand those, that's fine. This flow can really be applied to any architecture. And yeah, the benefits of the tooling, I'll get into these more later, but more consistent outputs. It runs faster because it's based on Python scripts at a lot of points. And I'll talk about this more in a bit, but it sort of provides a spec step, which reduces the overhead of AI mistakes by allowing you to correct them early in the flow. All right, so I'm going to start by just going through how this looks from the developer perspective. It's very simple. You start with the end state goal that you're trying to work towards. So most obviously, and most of the time, this is a screenshot. And then you end up with a set of enriched files following our architecture. And it's just 3 easy prompts to get there. The first is to write a text spec based off the screenshot provided. You drag and drop the screenshot in. The next is to generate boilerplate based off the text spec. And then the third step is to enrich the boilerplate. I'll stretch the Lego analogy a little bit further here to break down or analogize these steps. So the first is, you go from the goal, so the picture on the box, the final state you want, and the first step is to translate that into a blueprint. The first step is to translate that into a blueprint, and then the next step, and this is where the analogy gets stretched a little too far, but the next step is to create the actual Lego blocks. Those are the boilerplate components. And then the enrichment step, the final step, is to do a little bit of the construction of the tower. I know this is all sort of high level. I will get into the actual implementation now. So how does this actually work? I'll go through each of the steps and talk about what is going on in the background. So yeah, first step, write me a tech spec based off this screenshot. This will invoke a cursor rule. You don't need to read all this. This is just three kind of random steps from within that cursor rule. And it walks the LLM through a tech spec template and tech spec examples and how to convert that screenshot into the tech spec. Here I just highlighted one example step where we tell it how to name the properties in our view states. And you don't need to really understand the details of all this architecture. It's more just a high level. This converts the screenshot into a tech spec. I'm not going to actually look at the full tech spec right now. I'll just stay in the slides. But we do have this slide here, which zooms in on a part of the tech spec. You can see that it's this YAML format, and it allows the developer to go in and change some stuff, maybe some incorrect assumptions that the AI made. This, what we're looking at here is the view state. So the view state is all the properties that are going to be configurable in your view. So let's say, for instance, we want to change the opponent name to be player name. We can do that now in this at this spec stage before the LLM has generated, 4 files with this property, however many times throughout. I'm gonna show the full flow at the very end. So if this doesn't make a ton of sense right now, hopefully it will by the end. All right, so step 2 is to generate boilerplate based off the tech spec. So after the developer has reviewed the spec, they say generate boilerplate, and it calls or it invokes this other cursor rule, and it's longer than just this one line, but this is the most important line. The rule calls this Python script, which parses the tech spec and then pulls in all of our existing Xcode templates and enriches them. So yeah, I'm calling this out because these are also just standard Xcode templates, which you can use through Xcode. So it's sort of nice that they have this dual use and they serve as a source of truth for our architecture. And you get a set of files like this, and they should be fairly bare bones and not really require much review because they are just enriched templates. Final step, step 3, is to enrich the boilerplate. This step is the most LLM driven. It actually invokes a number of cursor rules. So it invokes sort of this parent cursor rule, which calls a bunch of child cursor rules. And you can see an example from one of the child cursor rules. This is the one specifically for enriching our view state publisher. And it's directing it on how to correctly use strings. As you can imagine at Duolingo, we do a lot of localization, so we're not passing around raw strings. And yeah, so this just cues it into that little detail, and there's tons of other little details about our code base that we can put in here. And the nice part is that because we're working off a very structured set of Xcode templates, we can tell the cursor rules, like, look at this exact property, and this is how you fill it in. Look at this exact function, and this is how you fill it in. Yeah, this is just expanding on that strings point. You can see how the cursor rule produces code with correct strings, handling just standard strings correctly, and also strings with properties. And all right, so a question that we get a lot from product engineers is, what if I'm not creating a full new screen? Because this is not that common of a flow. And we're still working on building out these other flows, but from a high level, if you can formulate what you're trying to do into that tech spec format, you can then use these tools. So another example is going from a data model to the storage layer. So say you have, I don't know, user preferences struct, and you want to add storage for it. What you do is you just say, write me a tech spec to store this data model. It will generate that tech spec that I showed you earlier. And then you say, now generate boilerplate based off this tech spec. If you're paying attention, you might be wondering why there's no third step here. And that's because actually for generating the storage layer, you don't need to do any enrichment. It's all just procedural Python scripts and templates. There is actually a touch of LLM fixing at the end of step 2, but for the most part, it's just script based. All right, and then one other thing I wanted to call out is that we tried to structure our cursor rules to be narrow so that they can get invoked in more general purpose scenarios. So if you didn't go through our tooling flow and you still want to use one of these cursor rules to fill out a view, you can do that. Just say enrich this view, and it will go through that cursor rule and queue the LLM into all of our, the components that it should be using and how to use colors and everything like that. And then most importantly, are people actually using this tool? And we only introduced it 5 months ago, but so far, I'd say the adoption has been very strong. I work on a lot of internal tools, and I know the hardest part is always getting people to change their behavior and actually use them. And relative to previous experience, I'd say we're kind of roaring out of the gate with this one. So we have about 70 components merged into our code base now that were generated using some part of this flow. And then we've also gotten a lot of great anecdotal feedback. I wanted to highlight a few quotes here. This is from one developer who says that not only did it save him 2 hours of confusion, it also saved a lot of back and forth on reviews. So this is just to highlight that this is not only saving time for the author of the code, but also for the maybe more senior engineer who's going to review it and need to give feedback. And then I'm highlighting this feedback here because they say it's been useful not only for speeding up their feature development, but also learning things because it's pointing the developer in the direction of the correct way to do things. So they learn the architecture as they use the tool. And then this feedback here I got unsolicited, and it was really great to hear. This was someone who used the tools to build a feature in using our architecture for the first time. And yeah, they said they wrote more tests in the past 2 weeks than they had in the previous 3 years. So just to say that there's a lot of downstream positive effects of these tools. Once you make it easier to do the right thing, you get a lot of, good things after that, like tests. And yeah, just to get ahead of this question, is this for cursor only for folks who like Claude Code better? It does work for Claude Code. I'm not going to get into the details of it right now, just for time's sake, but this is kind of a ridiculous AI generated image. So we have like a whole syncing process so that our cursor rules get copied over into the Claude MD right now, and then all of our other like MD files. I didn't build this, or my teammate Kush did. If you have questions about it, I can try to answer, but I'm not an expert. All right, and now what do we learn about AI more high level, since this is a hot topic? First off, scripts are really powerful when paired with LLMs. LLMs are really good at writing Python scripts, and then they're even more powerful if the LLM calls the Python script and then does a little bit of follow-up on it. So you get that deterministic expected output from the script, and then you can do the more complicated stuff with the LLM. Templates are really powerful, both because they set some initial guardrails for the LLM, correct architecture, for instance, in this case. And then another thing that's nice with templates is you can insert to-dos and other comments in the template, and those serve as additional prompts for the AI. So you can say, look at this template and look at all the to-dos in it and fill those in. And then specs are really important when using AI. So they give an intermediate step, which allows the developer to go in and fix AI errors and assumptions before lots of code is generated. And then they also create a standardized process allowing for multiple different starting points. So like the data model versus screenshot, and then you can funnel it all into the same tooling flow. So what is next for our work? We've got a lot coming up. First off, there's just a lot more boilerplate and code gen possibilities here. So we have a lot of animations at Duolingo, and that involves a lot of boilerplate. So we're looking into how we can create templates and flows for that. Yeah, also maybe KMP. There's like tons of stuff that we could extend here. We also are looking into migrating legacy code. So yeah, our code base is far from perfect. We have a lot of screens which don't follow our MVVM architecture. And so we're exploring like, hey, can we take a screenshot of that existing screen and put it through our flow and rewrite it using the correct architecture? And we've actually already found that this is very powerful because you can say like, hey, look at this existing implementation for the actual logic and use this flow for the architecture. We've just started exploring this, but I think we can refine this flow more and maybe do some, major refactors on mass. Yeah, and then another thing we're looking into is more iterative flows. So just like people aren't really writing new files that often, so we want to look into building tools which iterate on existing files, but that gets really hard when you don't have a very consistent architecture. So we're thinking the migration bit might come first. And then tracking, we just want to get a better sense of how often these rules are invoked, how many lines they're generating that people actually like. And that will help us understand when we're making changes that are positive and when we're not. All right. I think there's enough time to show a quick video of going through the flow. Yeah, I sped it up super fast, and I also cut out a lot of the LLM thinking, so it doesn't run quite this fast, but it's faster than just an LLM code gen process. So yeah, you start by copying and pasting the screenshot into Cursor or Claude, ask it to generate a spec. This is the spec it generated. You can see it defines the destination paths for the files. So this is where the data layer and view layer files are going to go. Let me pause it, it's going a little too fast. And then it defines all of the data layer models that are going to get created. And then it also defines the repository that's going to get created. It created a paginated repository here because if we look at the view again, let's look at the view again, just assume this would be paginated. I don't think it needs to be paginated. So then as a developer, you would go in and say, actually, let's not make this a paginated repository. So that's why the review step is important. And then you can see how it's defined the view here. It's named the view activity center. So that means it's going to create an activity center VM, activity center VC, activity center view. You can change that name if you want to. We're defining the UI framework here as UI kit. You can change this to SwiftUI. Probably should change it to SwiftUI. And then we have our dependencies. These are all the repos that are going to be injected into the VM and used to produce the data for the view. And then also we can see that the LLM was smart and noticed that these are repeating cells. So it created this sub view state with the properties for those cells. And then finally, at the bottom here, it defines a set of view components. It like goes through our code base and our components library and says, like, these are the components that are most likely to be used for this screen. And this gives the developer an opportunity to go in and say, hey, actually, I want to use this other component instead. You can think of the spec as like the most abstracted version of the code. So next step, generate boilerplate based on the spec. This calls the Python script that generates these template files. I just very quickly go through them here. They're very, there's really not much LLM intervention. So you can see the VM is very sparse, and same with the view. So yeah, after you review that, and sometimes it makes sense to put those files up for review before you do the enrichment step, because the enrichment step adds a lot of code. And so you want to keep your PRs small if possible. Now we can see that the VM has a lot more code in it. Sorry if it's going a little fast. All right, so I'm highlighting here how it's using strings correctly. This is something that the LLM doesn't always do if you just ask it to build a screen for you. And we can see the view here is also enriched now. And then I highlight how, so it's using here a reactive list view, which is our internal component for lists. And it's something we want developers to use instead of collection views directly. I'm just calling this out as a small example of how this flow points developers in the direction of the stuff we want them to use. It's also using our custom insets. It's doing colors correctly. We tell it exactly where to find our colors, and I think that's it. So that is the full AI code gen flow. Questions? Okay. Are we giving out plushies? Yes. Okay. We're giving out plushies for people who ask questions. I don't know. Okay. I'll just start front to back. So yeah. Paul?
I use the microphone and pass it out.
Oh, yes, please. Yeah.
Awesome. Thank you very much. Great talk. You mentioned in passing KMP.
Oh, yeah.
Question, what is KMP, Kotlin Multi-Platform, used for Duolingo? And do you use this tool to generate KMP? And is this a plan maybe in the future? Because my next question was, how does the tool know if it should be writing KMP code or Kotlin code or Swift code?
Right. Okay. KMP in general, I'm definitely not the person to ask about. We do use it for chess right now, I'm pretty sure. I'm not... What's up? Adventures also.
Ask questions.
So I was saying that as something we might build in the future. Right now, we haven't built it. Hypothetically, and this is where the spec, we're dealing with the spec getting really big, and we want to, I don't know, we need to find a solution for that. But the short answer to your question is we don't know yet. We'd find some way to abstract that into the spec, hypothetically. Yeah. Okay, I'll keep moving. So everyone's got a question. Yeah, let's, Chris.
Yeah. Have you pushed this tool to see its limits? Do you have guidance for the users of it to say, like, don't upload a screenshot that's this complicated or a data definition that is this complex?
Yeah, it is something we're contending with. Obviously, the more complex it gets, the more likely the AI is to make mistakes. I do still recommend people use it for pretty much every screen they're building, because at the very least, it will, cue them into the correct patterns. And maybe they just used it as reference. Like, for instance, it will show them to use the reactive list view instead of a collection view. And there's lots of small details like that. And even if it's not able to one-shot it and it's not able to one-shot it for pretty much any view, I think it still does get people pointed in the correct direction. And then we also have very explicit steps in the cursor rule to add in comments above things like layout, to be like, this layout is definitely wrong. Go in and fix it. This is just to get you pointed in the right direction. Yeah. Should we skip? Yeah, we'll go from front to back.
From front to back. If you want to flush it, come to the front.
So not necessarily a coding question, but curious from, I saw you had the feedback from engineers as how things were going. I was curious if you had any measurements or metrics around velocity and or cycle time. How's that been looking? What are you measuring? And yeah, how does it look?
Yeah, so that is one of the tougher parts of this. So that was one of also the things that we're working on right now, is adding more tracking around how many lines of code from this process actually get merged and generated. I was actually working on that today. If anyone has tips on that, I would be interested in hearing them. I wish that Cursor had better tools for this built in, but yeah.
Are you seeing an improvement in getting work either completed or shipped, I guess?
Yeah, so we just introduced the tools, so I think it's going to take some time to get that top line effect. So anecdotally, we're hearing people say it speeds them up by a couple of hours to days. Yeah. And also, yeah, there's also those sort of downstream effects that are positive. Yeah.
Yeah, just to follow up on the metrics, you showed absolute numbers of features. Can you give a brief, how much in percentage, like how many?
Oh, that is a good question. So I should look into that. Yeah, over divide over all the new files added. So I don't have the actual number on that, but I do get pinged every time someone adds a new component. And so I can see whether or not they use the tools on it. And I will say, I think it's hit an inflection point over the past week where almost all of them are using the tooling. Yeah, in some way.
And can I ask another one? You mentioned like the specs and the other parts of the specs that are generated on the one of the steps. Is it something unique to the LLM, or is it something you use in the workflow before in Duolingo?
Wait, sorry, which step?
The specs of the feature.
Oh yeah, so that was built for this workflow. We intended at first to have those specs go through some kind of architecture review, and you could still do that, but people haven't really been doing that. Yeah.
Hi.
Hi.
So earlier you gave the example of the reactive list view, as in, hey, don't use the regular list view, use our optimized in-house version that's like probably super performant or whatever. And like, you know, for any like kind of company, once you reach a certain size, like, or code base, once you reach a certain size, you're trying to build a design system, whether it's like a design for certain components that look a certain way, or certain components are built in a way that makes them performant, or like, you know, have like specialized APIs. So how are you making sure that the LLM knows to check? Is it, oh, every time an engineer creates a new reusable component in a design system, they edit the cursor rules? Is there some sort of retrieval system that you're building?
That is a good question. I think we're still, yeah, because we just created these, we haven't created a process for that yet. We are on the same team, the people who in the design system.
So how did it know to use
use
reactive list view when it's writing the code?
Oh, so that is in the cursor rule. So there's an explicit step in the rule saying if you're doing a list view, use this component. Yeah, but in terms of
right now, it's very ad hoc. One line, like specific ones you just have to use, but it won't like if the follow button exists in the code base, you won't necessarily always have a rule that, oh, here's a follow button, like when you need to build a follow button.
Yes. We do have it read all of our design docs before doing anything. So hypothetically, if you add something to those docs, the LLM will be aware of it. But when it comes to like things we really want to push, we have explicit steps in the rule for it.
Hi, Carter.
Hi.
Because you broke it down to three basic steps with Python, like do this first and then boilerplate and then enriched boilerplate. I'm guessing that hallucinations are now minimal, but have you seen it happen?
Yeah, definitely. I mean, it's not one-shotting things. You need to go in and fix stuff. And the intent of breaking it down like this is so that, say, you're someone who doesn't really like trying to one-shot it, you can still use the boilerplate steps. You can go up to step 2 and then say, merge that and go through your own workflow from that point forth. So yeah, the third step is the most LLM kind of hallucination prone, but because the cursor rules are so structured and detailed, it's reduced the error rate, I'd say.
Like you tamed it.
Sorry? Yeah, trying to. Yes, exactly.
Hi, Carter, thanks for your speech. And because in today's speech, talk about how you transfer from a screenshot to the boilerplate. But I remember I saw in the Duolingo website, it's pretty much backend driven. So the product's pretty much backend driven and then front end. So how you describe how shape your backend process?
Yeah, so actually only, I don't know exactly the screens, but there's only a couple screens that are server driven. Maybe there's a blog post about it. Is that what you're talking about? Yeah.
Backend driven something.
Yeah, so that's only a handful of screens. Most of our app is still client side. Yeah. So this process would not be for server driven UI. Maybe we could build it for that, but yeah.
Still client driven, client heavy side, right? Or product still client driven, client heavy.
Yes.
Hi, Carter. Thank you. It was really interesting. And you mentioned that you can use that in like Cloud Code and Cursor, but you haven't mentioned Xcode. Why?
Yeah. Well, I mean, honestly, the way I develop now is I start in Cursor and then I go over to Xcode. So I know Xcode tools have gotten a little bit better lately, and honestly, I need to do more research to see what we could do on that front. But yeah, honestly, there hasn't been a ton of demand from developers, so we're just kind of reacting to that. Yeah.
Thanks for the call. How long did it take to do these tools and to fine tune to a level that's usable for everybody else?
Yeah. So I was working alongside two other folks, and took us maybe a quarter to do all this, but then another quarter to fine tune it. And a lot of the work was doing one-on-one demos with product teams. I could do a whole presentation on how we kind of like proselytize this tool. And through those demos, we got a lot of good feedback, which we incorporated into the flow. Yeah. And that took a quarter. Yeah.
Is there a specific reason why you chose screenshots as sort of the primary input for your workflow? Or I guess my question is, could you feed it like product requirements as well to sort of reinforce the process?
Yeah, you can feed it all the context. I don't know. I don't know what the sweet spot is there. You can also feed it a Figma link if you have the MCP set up. We start with screenshot just because it's the least complicated, the easiest to demo, and I think people just wrap their heads around it easier. But yeah, you can throw in a spec in there and whatever.
Yeah. Hi, how you doing? So I have a question about the flow itself. So you're showing the Python scripts and then going to cursor. So I was wondering if the Python scripts are actually using some LLMs. Is there any, I guess, is there any step there that's using LLMs and then going to cursor for more like user input, or everything's happening in cursor, right? And I wonder if there's been a consideration about it, probably having those steps even more streamlined by including those in the Python scripts.
Wait, I'm not sure I follow. Say it again.
Sorry. Yeah. So I can repeat the question. Yeah. So essentially, it's like, are you only using LLMs, or I guess like going to LLMs when you use cursor, or are the Python scripts also calling LLMs and doing like queries and questions and refinements, I guess, based on.
Yeah. So it's the LLM calls the Python script, and the Python script doesn't call the LLM. So the rule is designed to call the Python script and then review the output of the script and add to it.
Yeah. Essentially, anything that's generating
Yes. So it's just 3 prompts in cursor. From the user perspective, it's pretty simple. Yeah.
We have a problem. We have another 10 questions and we are running out of time. And we also have a lot of questions online. So I'm going to take another 3, and then you're going to have to ask your questions during the break. Sorry, everybody. It's too many questions.
Hello. When you're building out the tech spec, I noticed that you can pick either UIKit or SwiftUI. I found that pretty interesting. Don't you think adding that level of flexibility can lead to inconsistencies in the code base?
Yeah. So we are making, this might be a little embarrassing for folks here, but we're currently making a push to SwiftUI. And the reason it defaults to UIKit right now is that I'm trying to make this tool as friendly as possible. So I don't want people to be scared because like, oh, I need to learn both this tool and SwiftUI. But in the not too distant future, I would like to have it default to SwiftUI and not even be a toggle. So yeah, good point.
How do you tell the agent to make use of configuration scripts to build specs files? Do you change the rules, or is it something that's already been mentioned in your rules?
Wait, what do you mean by configurations?
Like property names and stuff. So pretty much basic configuration assets, because you can't go and change the rules every time you have to make a small change in those files, correct?
Okay. Sorry, the asset files?
Yes, separate configuration assets to build spec files.
Sorry, I'm not following.
So sometimes you'd have to use a configuration file to sort of like fetch different names that you'd have to use in spec files, correct?
No. I don't think so. I mean, the names are all just AI generated.
Yes, what if you want to control it from like an external file? That's what I meant.
Oh, I guess you could do that. We don't do that currently. So the spec, every step is designed to just like get you pointed in the right direction, and then you go in and review and correct. So if you don't like the names, or you want to use something else, you can just go in and edit that file. Maybe
there's no static file that fetches all these stuffs.
No.
Hey, thanks. Just for, I'm not sure everybody knows what a rules file is.
Yeah.
I'm just wondering in terms of scaffolding, I'm familiar with, I'm stuck with Copilot or using Copilot, and we have a bunch of different things in there, bunch of different ways of scaffolding and different levels of scaffolding, if you want to call it that context. Or is the rules file the only thing you're using? Are you using an instruction file? Are you using, how are you organizing how you're trying to scaffold the AI, if you understand what I'm saying?
Yeah, so the backbone of it is cursor rules. And I'm not super familiar with Copilot right now, so I don't know if there's an equivalent, but I think there's probably like MD files and stuff that you can. So what we do with Claude, for instance, is we just copy over the descriptions for each of our rules and the file path to the rule itself into the MD file, the Claude MD file. And so Claude is aware of the cursor rules. So maybe you can do something similar in Copilot. And yeah, so it's all the backbone is cursor rules. Cursor rules is sort of delegate out to scripts and templates, etc. Yeah.
Awesome. Thank you very, very much. Big round of applause. Thank you so much.
Hello, everyone. So today we will talk about the design in simplicity. And my name is Alexander Sayenko. I'm from Ukraine, so sorry about the accent. And I live in Jersey City, so sorry, New Yorkers. I'm a field CTO at Sigma Software, so basically I'm helping all the different teams with everything tech related. And I have an experience of more than 13 years with mobile development. So I had it all. And also, I organized back when I was living in Ukraine, a Kharkiv iOS user group, similar to what we have here as iOSoho, and also organized a bigger conference called iOS Ukraine, which was like one of the biggest conferences in Ukraine for iOS developers. So let's start with an agenda. I will talk a little bit about what is TCA for those of you who don't know what that is. I will talk about why we chose TCA. We'll talk about pros and cons, how we use it, and what else do we use. So what is TCA? Who knows what TCA is? All right, who's using TCA? Okay, almost everyone who knows what TCA is using TCA. That's good. So that's basically an abbreviation for decomposable architecture. And as they're saying in their repo, it's a library for building applications in a consistent and understandable way with composition, testing, and ergonomics in mind. It's fully open sourced, so you can go and see for yourself what's happening in there and how it works. Here is the link and QR code if you want to do that right now. But if not, I will share a presentation with Chris and Paul and Nikolai, so you can download it from there. But basically, if you're not familiar with the unidirectional architecture, that's what TCA basically is. The way it works, it has a store which handles like the reducer that mutates the state, and then state triggers an update in the UI, and then user clicks something in the UI, and it goes through the reducer and stuff like that. And it goes in circles over and over and over until you're ready. Who's behind the TCA? It was created by the Point Tree, which is just basically two guys, Brandon and Steven, and the community. Community helps a lot, and it's very active. So they have a Slack channel. So if you have the Illuminati, that's right. If you want to join the community and just like discuss everything TCA related and all other libraries from Point Tree related, feel free to do that. They're very active, and Brandon and Steven, they're always answering all the questions there too. So why we chose TCA? First of all, what were our requirements? I will not show you like the entire like 5-page document for that, but just few of them that would make sense. We wanted to have like 3 different iOS apps that would have like shared features. Some of them would be used by 2 apps, some of them will be used by 3 apps. And we knew that we will have around 50 roles with all the different permissions, all the different behaviors. So it will be a complicated and highly modular app. It's mostly thin clients applications that we wanted to do, and we had some limited offline support for one of the apps that should have like when internet connection is patchy, we should have like some actions that were stored for offline, and then whenever you have a connection, they will be pushed into the backend. It's iPhone only, and we supported only the latest major iOS version. At the moment when we just started to work on this project, it was like iOS 18. Right now we are targeting iOS 26, and we'll disable iOS 18 in a month or so. But one major caveat that we had only 4 months till the first release of the app, and that was like non-negotiable. So first of all, YTC, it's a very opinionated topic, obviously, in my opinion, and you will have your own too. But I love the unidirectional approach. If you know what Redux is, or like maybe you worked with ReSwift before, or some other libraries, I know there is a couple of them, you'll understand why. It's really easy to understand, and it's hard to get lost when you're using this unidirectional approach. I want to say that TCA is not a silver bullet at all. So please do not use TCA for every new project that you will start. But neither is any other architecture or approach choice. And you will know in a minute why so. Please always pick an architecture or whatever like technology or approach you do according to your business needs or team maturity or 1,000 of other different factors that you should consider. And as Carter was saying about that they are using MVVM, you can read Why You Need to Forget the MVVM by Thomas Ricard, who's saying that Apple is not presenting MVVM at their like talks at WWDC anymore. You just need to use MV, that's it. And even better, we have another article by Jacob Bartlett that says that SwiftUI is dead. That's because in iOS 26, they moved some of the components in Photos app to the UI kit, and they're like doing more presentations as WWDC for UI kit. So as I said, that's very opinionated topic, so please choose carefully and see what works for you. But main reasons why we chose TCA. First of all, it's the documentation. The documentation itself is very rich. You can find almost everything in there. It's supported and updated all the time, so it's really nice to use. The second one is the amount of examples. It feels like guys from Point Free put like every use case you can only wish for into the examples. So you can always see for yourself what's going on in the repo and how it's been used. They also have live open source complex application that is in App Store called isAwards. And they have a ton of features that are using like all the things like user defaults, push notifications, database, you name it. Just a ton of things that you can learn from and apply in your application too. And they have a ton of hours of explanation of the reasoning why they've created this architectural library and how to use it and what was the decision behind every solution that they've created. And as I said before, the community is really nice to talk to the guys, and you will have an answer for every question in there in Slack. So the final verdict for us was that it is an architecture that is really, where it is really easy to follow the pattern, and it has high modularity, not too cumbersome, well documented, and with ongoing support, like very frequent updates, and a ton of examples and a great community. And the best of it all, you don't need to handle all that by yourself because there is a community and guys who are taking care of that. So how we use it? When we just started, not everyone was happy because not all team members were familiar with the unidirectional approach. And it's something that you need to shift your gears in your brain and how it works. And it's very different to what you're used to while working with vanilla SwiftUI. Not everyone wanted to write tests. You know, not everyone wants to do that because it takes time. Right now, it's much easier with the AI, but you know, it's like useless code. So, there were a lot of words that didn't make sense, like reducers, actions, effects, dependencies. In terms of TCA, you don't know what to use and how to use, and you don't understand what that means. And you're having more boilerplate code than usual because it's compared to vanilla SwiftUI, it's much more verbose, but it has its benefits, and I'll talk about that more. And it was really hard to see the immediate results and immediate benefits because we started to write our apps and backend was lagging behind, and we were just doing something and it kind of worked, but we didn't know what's happening. But overall, it came up to us like later. But how it's going right now? So we followed the It's a Words example on project structure, and at the very beginning, it was really helpful. So we just like put every feature and dependency in its own target within its respective package. So we have very, very modular structure there, and we can use anything everywhere. And we also follow the latest case studies project on how to utilize every tool that they are presenting. For example, when guys from Point3 are releasing a new tool, they always update their case studies, or they put a new case study in there just to showcase how it works and how you should utilize that. And when feature becomes big, we split it into smaller ones, and it's not an issue at all with the TCA architecture. It's really easy to split things there. Every feature comes with a test, and I would not say that we do not accept pull requests without a test, but you should have a really good reason not to write a test, because especially right now, it's so easy to do with all the AIs that are available to us. And we have little to no merge conflicts. We have 6 people on the team, and we almost never merge conflicts because, as I said, it's very modular. I want to share like a couple of challenges we had. One of them is that our app became so big that we had a Stack Overflow, and we didn't know what to do with it first, and we were looking for an answer, and I'm glad that we found an answer in the repo. Basically, because in unidirectional approach, you have the entire state that is one for your entire application. It lives in Stack, and we wanted to move some parts of it to the heap. So we created like some property wrappers that are described here, and also in the Swift repository itself, how to do that and how to implement that. That helped us a lot, and we moved some of our like bigger parts of the state into that property wrapper that works as copy on write. And I want to mention that it's not a limitation of the TCA itself. It's rather than TCA highlights it for us in very prominent way because there is a single state. But Swift itself has some limitations. And another limitation that we encountered was also related to the Swift, because we had an enum that had 20 destination cases, and it was a lot. And it was also described in the repo how to fix that. Basically, what you need to do, you need to model a better model for your app, and just we created a few separate child features, and that worked for us really well. We just put those destinations into smaller enums. That's basically all the challenges we had that we were struggling more than 30 minutes on. And everything else was really easy to find an answer for in Slack or in the repo or just on the Stack Overflow. So when a new person joins the project, what do they do? First of all, we ask them to read the README in TCA repository. That's a long read, but it's worth it. Then we ask them to follow the Point3 step-by-step interactive tutorial. It's around like 4 or 5 hours of like step-by-step coding, where you understand like what the reducer is, how to navigate, and all those little bits. And then they implement a small feature in our code base based on other small features that we have. And it's really easy to follow. Obviously, a person usually has a ton of questions, and we are happy to answer them because we've been doing it for a year and a half now. And we know how to explain almost everything right now, what's happening in TCA. And then they just repeat the previous step with the bigger feature. And AI helps a lot with this also, because we have around 150 features right now in the apps, in all these three apps. And it's really easy to give it as an example, just do it like we have that in the other feature. And that's it. And that's how we onboard a new person. Of course, it's much more nuanced than that, but that's the basic gist of it. Let's talk about pros and cons. As I said, it's unidirectional, really hard to get lost. And you will always understand what's happening. No spaghetti code. You always know where action is coming from. It has a great modularity and composition. It's really easy to add a new feature, but what's more important, it's really easy to delete a feature when you don't need it. Because usually, it's much easier to add a new feature. And during the process of deleting the feature, you can encounter that you need to update like 150 files or something like that. It's not like that in TCA. It's very easy to remove it. Dependency system that TCA provides, it's really nice. It's testable. It's not just like the environment that you can use in your view and that's it, and you forget about it and you don't know how to test it. It really helps you to create some things like demo app that provides the dependency that was your API client, and you need for the demo to make a stub with it and just provide a nice really example for the demo only, and you can just replace any request or response within the dependency system for your particular purpose. Navigation is really easy to do and really easy to test too. You're not lost anymore. You can handle that very deterministic, and you know who navigates where, and they have tree-based navigation, stack-based navigation. You can mix and match that. And we actually haven't had any point when their navigation was not enough for us. Tests, tests, tests. That's what I encourage people to do. And it's very easy to write tests for TCA. They have a really nice library that helps you to understand what went wrong, what the exact place where it went wrong, and how to fix it. So it helps you, and if you have a QA team, like you will take some of their job, but it's really helpful. So please write tests. And the good part is not everything should be a feature. For example, if you have a very simple view that is just doing like showing terms and conditions, that's it. You don't need to accept them, just show them in the text or whatever. You can just do that as a view. You can ignore all the things that are tied to the TCA, and it will just work. So you are not tied to the TCA itself. And it has a very little room for error. So it's really hard to make a mistake that will not be spotted during the code review. And it's really hard for the person who writes the feature to write it wrong, because there are guardrails that you need to follow when you're using TCA. Cons. There is a lot of concepts to learn. As I said, like binding reducers, what is like action effect, how to do like a ton of things. You need to learn that, because that's a completely different environment and completely different approach. And because of that, it becomes very verbose compared to what we have in vanilla Swift UI. So please be aware of that. And as I said, a large single state could be an issue, but that's not something that you cannot solve. You'll just need to know where to look how to solve it. And another point is weak encapsulation, basically because you have single state that consists of everything, all the children. You can have access from the parent to the very bottom of your like children chain. And that's something that you need to be careful with. And but worry not, because TCA2 is coming 2026, and they're bringing a ton of cool features. So you'll have fewer concepts to learn, so no more binding reducers, binding actions, and all of that. We will have stronger and simpler encapsulation. We will have access to the stores dependencies from the view. We will hook to the feature lifecycle instead of the view lifecycle, because currently you just need to connect to the onAppear or task or something that appears when view just starts. And here we have an option to just connect to the feature lifecycle. We'll have more powerful effects, and guys will migrate everything to advanced concurrency. So that would be a nice thing too. We'll have better debugging tools. We will have SwiftUI bindings with less fuss because currently it's kind of, you need to write a lot of code. And the best part is that guys will release the point freeway, which is basically a set of skills that you will feed to your AI that will help you to generate everything. And they're saying that it will be released in early 2026. And I think it will be really nice because that's how they would do the project for you, but you will ask AI to do that now. What else do we use? We have a ton of other libraries from Point Free. Obviously, TCA itself includes like, I don't know, maybe 15 of them, but I wanted to highlight some of them that we are using besides TCA with our like modeling. These are like Swift identified collections, which is basically makes your array of items with ID really easy to work with. So you can like remove or update your array asynchronously and however you want to do it. They have Swift navigation, which is, as I said, has it like tree-based navigation, stack-based, and you can mix and match. And you can use it not only with TCA, but you can use it whenever you want in your any project. They have really nice Swift URL routing library that allows you to build really nice models for your backend. So you're not getting lost and you don't have like strings and that are like hard to read. You just like create a really nice cascaded deterministic routing for your backend. Swift tagged is another cool library that's for cases when you have, for example, a model with like several IDs. For example, you have a user with profile ID and user ID, and both of them are UUIDs. It's easy to get lost and use them like interchangeably. And this library helps with that. So basically that's more types on top of your basic types. Swift sharing is a really cool library that allows you to share something in memory or in keychain or user defaults, or you can do that through the file system. It's really easy to integrate in any part of your app also. And many more like non-optionals and all stuff like that. We can talk about that for hours. But what I want to say more about this, what we are using, and if you will take away only one thing from this presentation, let it be this slide, please. We are using like type-driven design in our application. It's not tied to the TCA itself. It's more about the way you're trying to compose your project, your models, and how you work with code. It's not tied to Swift also, but it was very popularized by my fellow Ukrainian, Alex Ozon, and in his blog, Swiftology.io. And he talks there about the type-safe validation, domain modeling with types, making illegal states unrepresentable. And the best of it all, it's architecture agnostic. So if you want, you can use it in your project like right away. You don't need to add libraries or anything for that. Just like take a look at that, and I promise you'll be a better developer after reading like just one article from that blog. So TCA is doing that in their like modeling of the libraries too, and in their samples too. So, and you should do that too. It will be much easier to understand and to consume for the person who is not a part of the project. And if you want to see the video, it's here, and Alex gave like numerous talks at all the different conferences, but you can learn from him a lot about that type-driven design. That's it. Thank you so much. And if you have questions, please free to ask.
So I saw you mention something about the Stack Overflow issue. Could you go more into detail about how you solved that?
Yeah, so basically in that issue on the GitHub, they have like a property wrapper that basically puts your struct, part of the struct in a class, or you can also put that in array. So it's not in the stack, it's stored in the heap. So you offload your memory, and it helps a lot in that way.
I've got a question. You said you have 150 features. Questions like around how they work together, like when you're working on one feature, do you build all 150? If you want to go from one to the next, or like, are you testing between features? How does that work?
Yeah, so because they're all put in the Swift package, we can build like each module separately, and you can test it right away. So if you have like a view there, you have preview, and you can write tests for that particular target, and that everything is stored in like package file, so you can run just tests for this feature. So it's very fast when you're developing a new feature, and because it like if it has imports from other features, it just like builds very fast. Between features, yeah. So tests are very nice to write because you can have tests for your feature that are very exhaustive. For example, like your small bits, small features have tests that cover like every bit of your feature, every action and everything. But if you have like your app feature, which is like the main one, and you want to test the basic flow and like user logins and stuff like that, you can turn off the exhaustivity and just test the actions that really matter to you. So that's how we do it.
My question is, you have so many features, and I think they're composable by using the TCA. But what about on the build system side? Are you also modularizing the features per target, per module?
Yeah, so we have like 3 Swift packages, and all of them have their own package Swift file where we describe every target as a feature.
It's a target. Okay.
Yeah, so we just compose like we have basically a folder for every feature, and it can have like their views or models or whatever they use. We also have a shared feature that we are using across all the apps. That's something that we
follow up to that is, do you see any performance related issues with that? Or have you encountered any performance related issues?
Yeah, so we don't have any performance related issues. It's even faster because you have such small bits of those features, and Swift build system can build that in parallel, and that helps a lot. It's much better than you would put everything in just like one folder on one packet, one project. No issues in runtime at all. Yeah. You're welcome.
I just had a quick question. I feel like one of the concerns I usually have about tying myself to a certain architecture is that in the future it might be hard to change. Did you ever have a concern that might become too tightly coupled to TCA?
Yeah,
Especially
of course.
if, like, requirements change down the line.
Of course, ask Flash guys where they are right now. So it's not only library; it's like the technology itself. It's always a concern, but I'm pretty sure that because Point Free is kinda, they have a subscription, and I'm a subscriber, and they have like some money out of this library. It's not just an open source that they're doing just for nothing. That's basically their work, and they're updating their libraries really often. I would say I'm much more confident in Point Free's libraries than I'm confident in like Apple's libraries, because you need to wait an entire year for that to be updated. And with TCA, you can just like report a bug and it will be fixed in the next release. So I'm confident with that.
Yeah, great talk. Do you use AI for TCA, and what's your experience with that right now?
So we do use AI, but it needs a little bit of like config to work properly. We wrote like the agents MD, and we currently wanted to add skills, but guys said that they will release their own set of skills. And sometimes it hallucinating and using like older versions of the TCA library because it's not aware of the new stuff. But if you just say to it like, please use this documentation, here is what we have, please use those features and as an example, then it works. And sorry? Basically, I'm just like, we don't have a predefined prompts. We have just like those empty files that we have that I've created basically using AI. And we do not write tests ourselves, almost never, because AI is taking care of that. And for features that are similar to the previous feature, you can also ask AI to do that. But if you really wanted to model something yourself, you can do that. So in our like PBX project, we have just like one file, which is basically app delegate. Everything else is stored within those small features, small modules. And we just import in the one app feature for the project as a library to the project itself. That's the only connection point between the project, Xcode project, and all the modules. And this app feature module includes other things that we are using, other small bits of the TCA features or dependencies or anything else that we are using. Is that what you were asking about? Oh, it's basically the same as you're importing whatever like third-party library or whatever you're using. Just say like import sign-in feature into our app feature, and you just use that. And that's it. Just like compose your views as you do normally, and you'll learn much more when you follow the like tutorial there. But basically, it's very simple view composition as you have. You just need to say that this view needs to fit from this part of the store. That's it. Thanks, everyone.